Hey, it's Mr. Shrum, and I'm in the Introduction to Biochemistry, the tutorial there, and we're going to go through the lesson activities in that lesson. And the first one is chemical reactions. So we're going to develop a model to construct an explanation for how atoms and molecules combine to form these new substances in chemical reactions, and it'll be relatively fun. So here we go. We're going to use a simulation called balancing chemical equations, and we're going to balance three equations. And there's also a little bit of a game, and it has challenges that we can do together. So here we go. PHET, P-H-E-T, interactive balancing equations simulation. All right, so when you get to this screen, we have these molecules here set up in this equation-like fashion, and you have various tools you can use. You can have none, but I like to use this scale because it's a very nice visual for what is happening on either side of the equation. You need the same number of molecules and atoms on this side as you do on this side. So here we have nitrogen and hydrogen. And if we add one of each to the equation, you'll see that we do not have a balanced equation as it stands. So we have two nitrogen over here, but only one nitrogen over here. We have two hydrogen over here, but three hydrogen over here. Okay, so we need to maneuver this around to make sure everything is in balance. And one easy way to do that is to add another ammonia molecule. We have nitrogen, hydrogen, and that makes ammonia. And if we add that second ammonia molecule, we have a balanced nitrogen set. So we have two over here and two over here. But the hydrogen, there's two over on the left-hand side and six on the right-hand side. And we can just add two more molecules and we get a little smiley face. Yay, we did it. And that is that. So we have to keep everything symmetrical. Not necessarily nitrogen and hydrogen are not set up in the same way since they're combined in different molecules now, but the individual number of atoms has to be the same. Water, so we have water being separated into hydrogen and oxygen. We added an H2O molecule on the left, hydrogen and oxygen. On the right, our hydrogen are balanced now, but our oxygen, that is not the case. So we have two on the right, one on the left. We add another water molecule that balances out our oxygen. And now we just add hydrogen to the right-hand side to finally get our balanced equation and a smiley face. It's approved. There we go. And lastly, we have the combustion of methane equation. We have carbon, hydrogen, and oxygen. Add some to each side. And the products of combustion are always CO2 and water. So any combustion equation, or you hear combustion, think about CO2 and water being the products after that reaction. And we added methane, oxygen, and CO2 and H2O. Carbon's balanced, hydrogen is not, and neither is oxygen. So we'll start with oxygen. We'll add oxygen to the left-hand side. I'm going to add some hydrogen, and that's it. So methane, oxygen, CO2, and water, H2O. And did you see how that happened? Okay. So right here, I saw oxygen. There's 3 on the right, 2 on the left. So I'll add 2 to the left. And now we have 4 and 3. I also see that we need hydrogen on the right-hand side too. And then I added an H2O molecule. And that balanced out carbon, hydrogen, and oxygen. Okay. So cool beans. Let's go back. It says we can go to the game and select level 2. I'll wait and answer some of these questions with you. Based on your experience in that simulation, what do the numbers 3 and 4 represent in 3NH4? Well, that first number is the number of molecules. There are 3 molecules, and within each of those molecules, there are 4 hydrogen atoms. The scales shown in the introduction measure mass, or the amount of matter in a particular object. The scientific law of conservation of mass states that matter cannot be created nor destroyed during a chemical reaction, but it can change from one form to another. Did the simulation support that law? Why or why not? Well, it did, of course. Both the scales and the graph in the introduction showed that the mass of the products and the reactants were equal, even though the forms of the molecules changed. In the simulation, atoms and molecules formed new molecules during the chemical reactions, but the number of each type of atom stayed the same. Precise measurements are important for scientific accuracy. Use the game to explain why precise measurement of reactants is important to form the desired products in a chemical reaction. Well, the game showed that the desired products cannot form if we do not begin with the correct number of atoms in the reactants. This means that scientists need to precisely measure the reactant before the reaction starts so that it yields the desired products. So this is a very important part of why balanced equations matter. If we are trying to create a certain amount of something, we need to calculate out what we need to start out with on the left-hand side. So if we know what we want on the right-hand side, we need to determine how much to actually put in. We need to calculate the inputs to get the correct output, right? And another way to think of that is cooking. All right, so you want to create a certain amount of food for 4 people. Say, mom, dad, grandma, you, or whatever your situation is. You're trying to feed 4 people. Well, if you make only 1 serving, right? You look on the box, says 1 serving, you cook that up, you don't have enough food for 4 people. You need to quadruple that recipe, and then you have enough food for everybody. And it's the same situation here. Think of it as a chemical recipe that you're trying to whip together. Based on the simulation, write a definition for the term balanced chemical equation. I think it's really intuitive, but it's a way to show how the number of each type of atom is identical in both the reactants and the products of a chemical equation. That's the example here. The following equation shows the correct molecules formed in the reaction, but the products are incorrect. So they screwed up. How would you correct the products? Explain your reasoning. All right, so we got methane, we got oxygen, we have water and CO2, but it's not balanced. So there should be 2 more hydrogen atoms and 1 more oxygen atom. This imbalance can be corrected by placing the number 2 in front of H2O on the reactants side. And that's it for that lesson activity. Then we have something about an unusual diet. And I can't play this video because it'll get taken down on YouTube. Because YouTube kind of sucks when it comes to copyright and free use. And so you can watch that. It's about this British lady only eating chips, potato chips. And she is able to survive on that. It's not necessarily the healthiest diet, and she's missing a lot of nutrients and vitamins, but she is consuming enough carbs and energy to actually function. Assume she eats 150 gram bags of potato chips each day. Use the USDA food database to calculate Deb's calorie consumption and the number of grams of protein, carbohydrates, and the total fat that she eats. So I'll show you what they say. So they picked Ayer's baked ripple cut potato chips. If she ate a total of 450 grams, that's 150 grams times 3, these potato chips every day, she will consume about 1,930 calories. And that calculates to 32 grams of total fat. If you grab a bag of chips and look on the back of the nutrient information, you'll find something similar. 32 grams of fat, 32 grams of protein, and 353 grams of carbs. So potato chips, potatoes are very starchy. That's why there's all that. Carbs, it has some protein, of course, and then fat, the oils used to actually cook the chips or crisp the chips. That is why the fat is actually that high. It's actually higher than potatoes by themselves. Part B. So now we're getting into nutrition, and this is a fun topic for me. So for every gram of protein, there is 4 calories in that gram of protein. Same with carbs and or sugar, 4 grams, 4 calories per gram. Fat, on the other hand, has 9 calories per gram. It's actually very efficient at storing calories. It's recommended that most adults eat carbs in the range of 45 to 65% of their diet, protein making up 10 to 35% of their diet, and fats making up 20 to 30% of their diet. Does Deb's diet meet these recommendations? Support your statement with calculations. No, it's not surprising. She is currently eating 128 calories of protein, 289 calories from fat, 1,413 calories from carbs. So only 6.6% of her diet is from protein. 14.9% of her diet is from fat. 73.2% of her diet is from carbs. Now, necessarily eating more carbs is not always a bad thing, right? Different diets for different people may be better. In certain cases, a keto diet has been prescribed for epilepsy or certain health conditions. You will need to tweak your diet. But I've been on a relatively higher carb diet, higher protein, lower fat, higher carbs, and it works for me. So these are guidelines. They're not strict, but eating straight potato chips is definitely not the healthiest diet for you. As can be seen in the video, she's actually having some health effects because she's not eating a diverse diet. As long as you're eating a diverse diet, um, the percentage of what you're eating, it matters less. As long as you're getting those macronutrients, micronutrients. The next step is if you're trying to tailor your diet, or if you're some type of athlete, then you would definitely tweak your diet even more. But Deb is on the slender side. Being slender is not necessarily bad at all. She doesn't have like a lot of muscle mass on her frame. This reflects a lack of protein in her diet. Sure, protein is necessary for building muscle and repairing muscle, but the body is actually surprisingly efficient with the protein that it can get. She also complains of bleeding gums and no nail growth. Those are symptoms of protein and vitamin deficiency. So she certainly does need more minerals and vitamins in her diet. Potatoes are good, right? They're not strictly unhealthy, but to solely depend on them for your diet, that is when things get a little out of hand. You need balance and diversity in your diet. You know, it says eat the rainbow. Have you ever heard that? So you need those dark leafy greens, those vibrant oranges, red peppers, apples, pomegranates, even grains, lentils, beans, legumes. Some people consume dairy, eggs. Other people don't. You know, meat sometimes as well. What do you think is meant by this statement? The human digestive system is very efficient at squeezing everything it can out of any food. Well, how do you think that relates to the way biomolecules are broken down and used by the body? The statement means that the human digestive system can adapt to extreme diets in order to survive. Carbs can be broken down into sugars and used for energy, but when carbs are not available in the body, it can also break down fats to provide the body with the required amount of energy. This explains why Deb has enough energy to keep going, even on her extremely limited diet. All right, so that's it for the biochemistry lesson activities. I hope that was helpful. And if you have any more information or questions you need me to look at, message me in Canvas or email me. You know where to find me, and I will help you out as soon as possible. But until then, have a good one, and I will see you all later. Bye-bye.